Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamboro. Today in our lesson, we're going to focus on electrochemistry. So it means we'll be doing both question 8 and 9. Now we won't be necessarily be teaching you, but we will be doing revision. So we're going to focus on papers from other provinces that they wrote now during the prelims, so that you can prepare yourself and be ready for the final exams. This is question 8 and 9 under chemical change, and we're hoping that you are going to get as many marks as possible. As you know, paper 2, we are saying we have 10 multiple choice questions and 20 marks. The structure of the paper, as well, the structured questions, we are saying is 130 marks. The total of the paper is 3 hours. You're going to write for 3 hours out of 150 marks. And then if you can look, the first part of our lesson, we'll be focusing on galvanic cell. The main thing here, the issue of definitions. Remember, we're always saying use the exam guideline to define. So we are saying continue to use your exam guideline for your definitions so that we can be able to move forward with no problems. So you will tell us what is oxidation. I think by now you know that loss of electrons is oxidation. Don't forget that. And we are saying you must know what is a reducing agent. We are saying a reducing agent is a substance that undergoes oxidation. And you must know that that substance that undergoes oxidation, the reducing agent, is oxidized, or its oxidation number will increase. So if you want to check whether a substance has lost electrons, it means you will see that the oxidation number will increase. And then reduction, we're saying this one is the gaining of electrons, which we call reduction. So a reduction is gaining of electrons, which is reduction. And that's where we find our oxidizing agent. So if we say what is an oxidizing agent, you will say it's a substance that undergoes reduction, or a substance that gains electrons, or a substance that is reduced. So you know that that is your oxidizing agent. So always remember those mnemonics that we are using there for you to be able to remember these definitions. And we are saying you must know what is an anode and what is a cathode. As we always emphasize that you can look at there for galvanic cell, an anode as a negative electrode. A negative electrode, and definition of an anode we are saying is an electrode where oxidation occurs. So it's an electrode where oxidation occurs. Hence we say an ox, so that you don't forget. So we're saying an anode is the electrode where oxidation occurs. And we are saying a cathode, we write cathode with a positive there, so that you don't forget that a cathode is a positive electrode. So this one we're saying is an electrode where reduction takes place. Hence we say red cat. The red cat is there to remind you that at the cathode, that is the electrode where reduction occurs. And we said reduction is gaining of electrons. So we always want to ensure that when it comes to definitions, you do very well. Now, the definition of an electrolyte, you'll find even in the question papers that we're going to deal with today, you'll find that you'll be asked to define what is an electrolyte. And we're saying this is a substance that has been dissolved in water. And when it's dissolved in water, it forms ion, and it forms ions in the solution, and that solution can conduct electricity. So you can say this is a solution that conducts electricity through the movement of ions. So you are able to define that according to your exam guideline. You are able to define electrolyte. And we are saying you must be able to know the relation of current and potential difference to the rate and equilibrium. So hence, when you look at the tables, you will have seen that we are having those reversible reactions. That shows you that we are talking about equilibrium here, and then hence we will refer to equilibrium. When do we say we are reaching equilibrium? Remember, we are saying that at equilibrium, the EMF of the cell will become zero. And then we are saying you must be having understanding of the processes and redox reaction itself, which is mostly what you did in grade 11, where you define redox reactions as the oxidation reduction reactions that you have done there. You were using the oxidation number. So it's very much important that that information of oxidation number, you keep it alive. Remember, if you are having magnesium, for example, as Mg, you know its oxidation number is 0. But when you have Mg2+, its oxidation number is +2. And always remember the issue of oxidation number. So we are saying before you do that, the last thing is the standard electrode potential. We will ask you to calculate the standard electrode potential for a substance, or we'll ask you to calculate the EMF. So what am I saying here? I'm saying some of the time will give you E of a cell, which according to the data sheet is E cathode minus E anode. You will see in the next slide, I think we're going to get that formula. And then we are simply saying that now this E of a cell, some of the time, will give you E of the cell, which will refer to it as initial EMF of the cell. So we'll give you the initial EMF of the cell and give you either the cathode or the anode. Then we ask you to identify the other electrode. Or we'll give you the cathode and the anode, and then you are able to calculate. So always when you're dealing with the questions, check what you are given. Am I given the cathode and the anode, or am I given the EMF and 1 between the cathode and the anode? Then you are able to calculate the other one. So that is very much important. So we'll be using the table of standard reduction potential. Remember, we have table 4A and table 4B. We'll go through them so that we remind you what this table mean and how you must use them to answer questions. Now, we have done the definitions already, so I won't spend time much here. We define loss of electron as oxidation. We said that is the reducing agent, which you said is the substance that undergoes oxidation, and that substance is oxidized. So we did that, and those are the definitions that you will always remember. We talked about gaining of electrons. We said is reduction. We said the oxidizing agent is the substance that undergoes reduction. A substance that undergoes reduction, we said that is our oxidizing agent. Now you can see that a substance is oxidized when it loses the electrons. So just in real sense, we're saying the oxidation number increases. We refer to that as being oxidized. For example, I've shown you magnesium to say when magnesium loses 2 electrons, it's now oxidized. So when you say it's oxidized, we're saying that its oxidation number has increased. But if we are having, for example, zinc 2 plus gaining 2 electrons to form zinc, we'll say that zinc 2 plus gained electrons and it was reduced because it's starting with a +2 and ending up with a 0. So we have those two processes. We're saying they take place simultaneously, and you must know all of them. So we've done all these definitions, and I'm hoping that by now you understand the definitions. The other thing that I want to emphasize when we start with this lesson, have your table. Remember, at the back of your question paper, you are expecting to have your table 4B and your table 4A. So have those tables so that you are able to utilize them as we'll be doing our calculations, and have a calculator next to you because we'll be doing a lot of calculations when it comes to E-cell and when it comes to stoichiometric equations that we will do. You will have seen that now there is stoichiometry in almost all the questions that we are doing. So it's important that you always prepare yourself to say that we are going to do some calculations even in question 8 and question 9. So I hope that helps you and prepares you, and you are ready with your table 4A and table 4B. You are ready with your calculator next to you and a notebook where you will be writing some notes as we continue to do this lesson. Now, how do you use the data sheet to remember definitions? Remember, already we told you that the EMF of the cell is E cathode minus E anode. This is the data sheet for this particular question. So you're able to know that, okay, for the cathode is here with reduction. So hence we said is an electrode where reduction. Okay, so you can see already that this table helps you, this data sheet helps you to remember that a cathode is the electrode where reduction occurs. For example, if you are saying what is oxidizing agent, you are able to say oxidizing agent is a substance that undergoes reduction. If you are saying what is a reducing agent, you are saying it's a substance that undergoes oxidation. What is anode is the electrode where oxidation occurs. So you are able to see that all this helps you with the definitions, and we are expecting that you won't be losing marks on definitions. If you have forgotten any of this, you can come to this table and it will help you with some of these definitions. And we are hoping that you will collect all the definition marks as we emphasize. As I indicated, we're going to focus more on provincial papers that were written on question 8 and question 9, because by the end of this lesson, we want you to know the different ways questions are asked and different ways to respond to such questions. Now, our first questions will be based on galvanic cell. After that, we'll go and do questions that are based on electrolytic cell. Now, when you look at your galvanic cell, we are saying a piece of magnesium ribbon reacts with excess hydrochloric acid according to the following balanced equation. According to the following balanced equation, we are saying now a piece of magnesium. So you can see it's magnesium, and if you look at this, you will have seen this type of reaction when we're dealing with rates of reactions. So you can see that these reactions, same reactions can be used in rates of reactions, and it can be used in redox reactions. Now, if you look at this, we're having magnesium solid. So if we're talking rates of reactions, you will have seen that we have the surface area. We must have the mass of magnesium because it's in a solid form. And we're having hydrochloric acid, which is an aqueous solution. And you know that for aqueous solution, we talk about the concentration. So you can see that already here we're having magnesium ribbon, which reacts with excess hydrochloric acid according to this reaction to form magnesium chloride and hydrogen gas. Now, the question is saying, which one of the following is an oxidizing agent? Remember, by definition, when we started, we said loss of electron is oxidation. That's where we find our reducing agent, and reducing agent is oxidized. But for the oxidizing agent, we said gaining of electrons is reduction. That's where we get our oxidizing agent, and our oxidizing agent will be reduced. So it's very much important to know if we are saying which one is the oxidizing agent, we are saying which one will be reduced in this reaction. So we're going to look at the reactants. Remember, our agents are on the left hand of the equation on the reactant side. So it means this is an agent and this is an agent. Remember, the reaction happens between a stronger oxidizing agent and a stronger reducing agent. So always when you look at an equation like this one, you will know that here on the left, we have stronger oxidizing agent and stronger reducing agent. And if you have seen on the table of standard reduction potential, you will have seen where you have these metals, magnesium, zinc, copper, that side, you will have seen there is an arrow there. I will show you when you deal with the table. There is an arrow there that is pointing upward on table 4B that shows that increasing, reducing ability. So you know definitely that magnesium or these metals are more likely to be your reducing agent. So you know that your magnesium will be reducing agent. We're going to look at that. Then let's check. In this question, what are you going to do? We're going to use oxidation numbers to answer this question. Already, we are saying that when magnesium is alone, its oxidation number is 0. When you are having HCl, you know hydrogen is a group 1 element. So we are saying that it has positive 1. Chlorine is group 17. So you know from chlorine group 18 elements, we're saying the oxidation number there, we're saying our charge there will be 0. And then group 17, it will be -1. Group 16, where oxygen is, will be -2 as we come backward to nitrogen, which will be -3. So you're able to check which oxidation number are we supposed to give to hydrogen. As a group 1 is positive 1. Chlorine, group 17, is -1. So you're able to put the oxidation numbers there. We go to the product side, and you see that chlorine, we said, is -1, but we have 2 chlorines, which gives us -2. So you can see that magnesium is +2. So in this case, magnesium has increased. The oxidation number of magnesium has increased from 0 to +2. So you can see that magnesium has lost electron. It has underwent the reaction called oxidation, which means magnesium is our reducing agent because it is oxidized. So oxidized simply means that its oxidation number has increased. So you can see that magnesium in this case is a stronger reducing agent, which means now between hydrogen and chlorine, we're going to look for our stronger oxidizing agents. And if you can check there, you are able now to check to say, okay, what is happening here? Hydrogen is +1, but hydrogen on the product side is 0. So you can see that hydrogen has changed from +1 from H plus to H, which is H2. So this is 2H plus to H2. So you're able to see that our hydrogen changed from H plus to H0. So you know that we have 0 there. So which means now that H plus or hydrogen ion has gained electrons, is undergoing reduction. And indeed, hydrogen ion were decreased from oxidation of +1 to oxidation of 0. Hence, we are saying oxidizing agent must be reduced. So you see that H plus has been reduced to 0. So with confidence, you are able to say our oxidizing agent, the one that gained electrons, the one that is undergoing reduction, is our oxidizing agent, which in this case is reduced from +1 to 0, which is hydrogen ion. So with no doubt, you are able to choose and get 2 marks to say the oxidizing agent is this one. So our oxidizing agent, you will see that is mostly positive because it is more likely to gain electrons. It has higher ability to gain electrons than the reducing agent. So I hope you got that and you'll be able to utilize that. Now they are saying in a galvanic cell, the salt bridge is responsible for. So remember, this question is here to remind you of the functions of the salt bridge, to say what do we use the salt bridge for. Remember, we use the salt bridge to complete the circuit, and to maintain electrical neutrality. How do we do that? Is by allowing to by ensuring that where we have more negative, that's where our cations will move. Where we have more positive, that's where our anions will move. So you are able to know that, okay, a galvanic cell is responsible to maintain the charge balance. This is the neutrality we're talking about, the charge balance in the cell. How is number B wrong? Number B is saying it allows for the movement of electrons. The salt bridge is not where the electrons move. The salt bridge is where the ions move. The cations and the anions, they move in the salt bridge to maintain electrical neutrality. So this number B is wrong because it's not the electrons that move. Number C, it says the salt bridge, the salt bridge allows the mixing of the two solutions from different cells. No, that's not what we're doing. We're not mixing them, but it's maintaining neutrality. And then it's saying, number D, the salt bridge is not necessary for the optimal functioning of the cell. This statement is wrong. Remember, without the salt bridge, the cell is incomplete. So 100%, number A is our answer, is there to maintain electrical neutrality by maintaining the charge balance in the cell. So that is the 2 marks that you got for that question. Now, let's look at the galvanic cell. They are saying the following balanced chemical equation represent a reaction when a galvanic cell is operating under standard conditions. Immediately when we tell you under standard conditions, you know that there might be a question that we might be asked about standard conditions. Remember, we have 3 standard conditions. In this case, we used to say when we're dealing with factors affecting equilibrium, we said there are three factors that affect chemical equilibrium, and you said it's Cape Town, you said it's CPT, which is your concentration, your pressure, and temperature. Here I want to emphasize, please don't write the conditions as concentration, pressure, and temperature. No, you must always write them with the values to say how much is the concentration, how much is the pressure, how much is the temperature. So in this case, the concentration, remember, concentration affects gases and aqueous solutions. So we must have gases here for concentration to affect, and you can see we have aqueous solutions and gases. Definitely concentration is a factor, and we are saying initial concentration of 1 mole per cubic decimeter. Pressure affects only gases, so there must be a gas that pressure can affect there. So I would always advise you when you're writing the factors to start with temperature and concentration, those two, because those two, they affect all the other reactions that we do. But if you check pressure, it only affects when we have gases. So let pressure be your number 3 in terms of writing the factors that affect or the standard conditions. And we're saying pressure is 1 atm, or 1, which stands for 1 atmospheric pressure, or you can say 101.3 kilo pascals. Your temperature, you will say 25 degrees Celsius, and you can as well say 298 kelvins if you want to use the Kelvin scales. So that is the question that is asked there. Write down 2 standard conditions under which this cell operates. So you are able to say concentration of 1 mole per cubic decimeter, initial concentration of 1 mole per cubic decimeter, temperature of 25 degrees Celsius. Now they say for this cell, write down the name of the formula of the electrolyte that can be used in the salt bridge. Remember, in the salt bridge, we need a salt, but we need a salt that can dissolve, that is soluble, that can be able to dissolve in water, that can be able to form ions, because remember, we want the ions to be able to move there, because the salt must be able to form the cation and the anion in order for it to maintain neutrality. So you can choose any salt that is that can dissolve there. You can use potassium nitrate, for example, as your salt, because potassium nitrate can form a cation, which is K+, and an anion, which is NO3-. Remember, learners, the cation would always flow towards the cathode. The anion would always flow towards the anode. For both these cells, you got to have that understanding that cations will go towards the cathode, anions will go towards the anode, because this is a negative electrode. Then the anions will go there to maintain neutrality. So please don't forget how the neutrality is maintained. Now, the next question, they say, write down the reducing agent. That is question 8.2.2. Write down the reducing agent. So you are able to look into that question and say, what is the reducing agent? Remember, the main thing that helps you, you know that the reducing agent, we said, is that one that loses electron, undergoes oxidation. We call it the reducing agent, and the reducing agent is oxidant. The one that gains electrons undergoes reduction. We call it oxidizing agent, and that one is reduced. But this question said we're looking for the reducing agent. So you look for the one that is which one is going to lose electrons. And I want to give you a tip. You see, we have chlorine, which is minus, and we have gold here, which is with an oxidation number of 3+, Au 3+. So you got to have the understanding here of saying, okay, fine, when you're having Au 3+, this Au 3+ is it's a stronger oxidizing agent, because it's more likely to gain electrons. Because when it's a 3+, it shows that it became 3+ by losing electrons. So it's a stronger oxidizing agent, while the chloride ion is your stronger reducing agent. Remember, we said on the left of the reaction, or on the reactant side, we always have a stronger reducing agent and a stronger oxidizing agent. So you won't forget that. So our reducing agent there will be Cl-, or you can say chloride ion. I've seen that majority of our learners, they will write chlorine ion, which is not correct. It must be chloride ion. The best way, just write Cl-. We will be able to give you 1 mark for writing Cl- as your stronger reducing agent. Now they are saying here, write down the cell notation. Write down the cell notation. Remember, for cell notation, we are saying you can say all clever learners. All clever learners. So you say all clever learners. Or you can say A, B, C. The A stands for the anode. So you must always start with the anode, then the salt bridge, then the cathode. Here you have already showed is the anode, the salt bridge, and the cathode. Always in that order. So already you have seen that at the anode side, because you have seen that you said chloride ion is the reducing agent, which means it's the one that is going to lose electrons. So chlorine ion is going to lose electrons, so which means we're having that Cl- becoming Cl2. So that's 6 Cl- becoming 3 Cl2. So that's how the electrons were lost. So the anode, we are losing electrons. Where we have loss of electron, that is our anode. So which means here you're going to have chlorine minus becoming Cl2. So you put a solid line between them, because these two, they have different phase. That solid line shows that they have different phase. Remember, If all of them were aqueous solution, for example, same phase, you will just put a comma between them. But because chlorine ion is aqueous solution and Cl2 is a gas, you put a solid line between them because it's indicating that these two have different phases. And remember, chlorine is aqueous, Cl2 is a gas. So for us to be able to conduct electricity, to allow the flow of electrons, we always need a solid. In this case, you're going to take platinum and use it as your solid. So when you don't have a solid, you are going to look for platinum to use it as your solid so that it's a good conductor of electricity. So your cell notation will start with platinum there because chlorine minus and Cl2, they are all not solids. We need an electrode must always be a solid. Hence, we are using platinum as our electrode there. And then you have your salt bridge. You can indicate the concentration of your solution to say your solution have the concentration of 1 mole per cubic decimeter. It's fine, but we don't penalize you for writing it in this way. So you are able now to say, okay, we've written on the anode side, you go to the cathode side. On the cathode side, we are saying Au3 plus is gaining electrons, gaining 3 electrons. So you have Au3 plus forming Au. Au is solid, so you don't need platinum there. So you will write your cell notation in that fashion. You'll see when I show you the memorandum. I just prefer that we first do it so that you see how you go about answering the question. The last question is saying, calculate the standard reduction potential of Au. Obviously, we're given the EMF as 0.14. So definitely you need table 4b, guys, learners, to be able to do this kind of calculations. This is table. Hence, when I started the lesson, I said for question 8 and 9, we'll need this table because this table is going to give us everything that we need. But remember, for this question, we are given that EMF of a cell is 0.14 volts. That was given in the previous statement. The EMF is 0.14. And chlorine, do you have chlorine on the table? You go to the table, you look for chlorine, and then if you check nicely, you are going to get your chlorine there. On the that will give you a Cl minus as your electrode there. So I just want to find it fast. Then you go to your table, you look for your chlorine, which is your Cl. There it is. Cl2, which is 1.36. Very much important. Now, we know two things. We know that chlorine, that we said is in the anode. We said our E anode, which is chlorine, we said is positive 1.36. So you're able to get those two. Then you can now be able to do the calculation because you now have to find your last electrode there, which is the gold part. To say the gold, how much for gold. And if you look for Au, you won't get it in this table. Hence, you were given the 0.14 so that you can be able to calculate it using the formula. Remember, you will go to the data sheet and know that you have E cell equals to E cathode minus E anode. Then you are able to do your substitution of 0.14, and for your anode, for your E anode there, then you are able to get everything that you want. So if everything is done and done correctly, you will have had your E of a cell, which is E cathode minus E anode, or E reduction minus E oxidation, which is 0.15. That becomes E reduction minus 1.36, and when you bring the 1.36 the other side, it becomes 1.5 volts. So you're able to see that your gold there will have standard reduction potential of 1.5. It's important that you always copy these things correct, the formula correct. You can't do the shortcut of saying EOA or RA all those things. You can't do that. You must definitely copy the formula the way it appears in the data sheet. I hope you got that one, and it will help you moving forward. And you can see how we go about marking your cell notation there. We have emphasized the issue of platinum. When we don't have a solid, that you will use platinum as your solid, and we have emphasized the issue of the salt bridge there, and then we've emphasized the issue that outside we start with the anode. All clever learners. So like that, or say APC, then that is the way you will do it. I hope this question paper helped you to have understanding, and when you get questions of this nature, you will be able to answer them. Now let's go to the question paper adopted from the KZN prelim, which says a galvanic cell is constructed using lead, which is PB, and magnesium. So we have lead and magnesium electrodes. The electrons will flow from there, then you are able to check. The main thing here, remember, electrons always flow from anode to cathode. So that is the understanding. So this question is simply saying to you, between magnesium and lead, which one is a stronger reducing agent? So you see the importance of a table, because immediately when you go to the table, you will be able to look for PB and Mg for lead and magnesium, and be able to check which one is a stronger reducing agent, because a stronger reducing agent is the one that will lose your electrons. So if I go to the table, yes, here we have a table. Sorry for that. If I go to the table, you are able to see that, okay, we're looking for magnesium and for our lead. So magnesium is there with a standard reduction potential of minus 2,36. So we're having magnesium with a standard reduction potential of minus 2,36. So now you check, you are looking for lead, which is our PB. Then you are able to look for your PB there, which is your lead as well. And then, so it's important that you look fast, because time is always not on our side. So we're having PB. You see, I want to emphasize this, that on the right, on the left here, if we check the arrow here, it's saying the arrow is facing downwards. It's saying increasing, the arrow on the right. As we move to this one, we're saying increasing oxidizing ability. The other arrow is saying increasing reducing ability, which means on the left we have reducing agents. On the right we have oxidizing agent. Let me show you this, because this is important, and I think it's something that makes you understand this topic. Because we're saying we have Mg 2 plus 2 electrons. The way it's written like this, which is Mg with a standard reduction potential of minus 2,36. And we have lead, that is written as Pb2 plus 2 electrons, forming Pb. And the standard reduction potential is minus 0,13. Remember, this table of standard reduction potential assists us to say the one with the highest potential. Remember, potential is ability. The one with the highest ability will undergo reduction, which means will gain electrons. In this case, the highest ability is 0,13. So you know that Pb2 plus is a stronger oxidizing agent, meaning that Pb2 plus will gain electrons. So we don't change this one, but we must write one arrow there. We don't write. Remember, when we ask you questions, there's nowhere where we expect you to write 2 arrows. You must write 1 arrow. In this case, we're saying for the strongest oxidizing agent, the reaction will remain the way it appears, but with 1 arrow. So I'm emphasizing that one, that Pb2 plus, because it's a stronger oxidizing agent, or it has a higher reduction potential, it will undergo reduction. Hence, you will write it like that, but with 1 arrow saying Pb, which means Pb2 plus will gain electrons, meaning that the strongest reducing agent, which is magnesium in this case, because the arrow is going up, is showing you that between Pb and magnesium is the strongest. According to this arrow, magnesium is the strongest reducing agent. So there are 2 reducing agents for every reaction, but the other one is stronger than the other one. In this case, on the reducing agent, we are saying magnesium is a stronger reducing agent, because as you go up, the reducing ability increases. So magnesium is a stronger reducing agent than Pb than lead, meaning that magnesium will lose electrons. And the question was saying, where will the electrons move? So you are able to see that the electrons will move from magnesium to the lead cell. So we go back to our equation, which now we know that, okay, the electrons, number C says magnesium half cell, the electrons flow from the Pb, lead, so these two are wrong because the lead is where we said it's not a stronger reducing agent, so it's not the one that will lose electrons, but magnesium half cell to the lead half cell. So we're agreeing that the electrons will flow from magnesium half cell to lead half cell. So we're agreeing on that one. Now, the issue here is, are the electrons going to flow through the Sol bridge? I think we talked about this at the beginning of the lesson, to say the electrons, they don't flow through the Sol region. It's the ions. Remember we said it's the cation ions and the N ions that flow through the Sol bridge in order to maintain neutrality. So magnesium half cell to the lead half cell through the conducting wires. Remember, with those conductors, that's where our electrons flow. So number D becomes your answer. I hope that question, it will help you and it will further increase your understanding of this topic. Now let's go to structured questions. They are saying the table below shows a half cell and an unknown cell B. You see, the importance of this activity that we are doing is that we want to do different ways that you will be asked the question, so that no matter how the question is asked. Remember, on the first question that we did, we were given the net cell reaction of 6Cl minus. You remember, reacting with gold, the Au2 plus. In this one, we're given half cell A, which is the silver half cell, silver plus and silver solid. So you have the aqueous solution and that one. But the half cell B, they are saying, is unknown. So sometimes we'll give you only one and not give you the other one, so that the questions will be about to finding, how do you go about finding the unknown half cell. The following observations were made while the cell was in operation. So what did we see? The cation ions. Immediately when you see cation ions, you are saying that this flows always to the cathode. I have overemphasized that the cation ions, they will flow, because these are positive ions, they will flow to the cathode in order to maintain neutrality. The N ions, or the negative ions, will flow to the anode to maintain neutrality. So in this case, we are saying our cation ions from the Sol bridge. Yes, we said the ions, they move through the Sol bridge. They will move into the electrolyte of half cell A. So you can see that, oh, cation ions, they move to the cathode. So this statement is telling you that half cell A, that's where our cathode is. And you know what cathode do? We said red cat, which is gaining of electrons. The reduction reaction will take place, which means we are looking for a situation where Ag plus will gain electrons to form Ag. That's what that information is telling you. It's telling you to say at the cathode is a reduction, which is gaining of electrons. And if you can go to the table 4B or 4A, you will be able to see that Ag plus can gain one electron to form Ag. Now, that's the reaction we're expecting at the cathode, because at the cathode there is gain of electrons. How do we know that this is a cathode? We're saying where the cation ions, or where the positive ions move, thus they move to the cathode. So half cell A is a cathode. Why? Because the cation ions are moving towards it. Now let's look at Roman figure 2 there. It says the initial EMF of the cell is 0.03 volts. This one is helping you now to solve this question that we're having. To say, okay, we know EMF of a cell. EMF of a cell, initial EMF is 0.03 volts. But we know silver. So our only job now is to go and look for the silver half cell. And then we can use the formula now to find the unknown one. You see? And that's how the questions, if you look at the trends, are going. It's either we give you the two of them, or we give you the EMF of the cell and either the cathode or the anode. Then we'll ask you to identify the other one from the table. In this case, they said calculate the E value, or the EMF, the standard reduction potential of cell B. So they want to know how much is cell B. So in this question, we are simply saying identify what is the ions there and the solution in cell B. Now, our job has been made easy. Then you need that table. You see, hence I said the table is your friend, because that's when you are saying, how will I get, you must go and look for silver ion and silver. Then we go to the table, we look for silver ion. This is our table that we have used before. And then you look for Ag. Fortunately, I got it faster. Ag plus Ag is 0.80. So you are able to go back to your question and say, okay, now I have the information that will help me to solve this issue, because I know for silver plus, we are saying for silver forming Ag, this cell, they have cell A. We are saying that the E cell is, E of that is 0.80. So you can see now you are celebrating. You write the formula, E of a cell is equals to E cathode minus E anode. E cathode, you must write it in full the way it appears in the data sheet. So you'll say E cathode minus E anode, and then you are able to say E of a cell. We're given that E of a cell is 0.03. That is equals to E cathode. Our cathode, we said this is our cathode because the cations are moving towards it. So our cathode is 0.80. Then minus E anode. So we're going to find out what is our anode here. Nice question. You transpose, then you have 0.03 minus 0.80 equals to E anode. And if you use your calculator, and your calculator is using 80 minus 3 is 77. So that will give you 0.77 volts. So you are able to go to your table and look for 0.77 volts, and then you will have identified the substance that we have there. So you simply go to your table, you look up to 0, 0.15, 0.77 is what we are looking for. Oh yes, you're able to see that, oh, this was ion 3 plus gaining 1 electron, forming ion 2 plus. So in this case, you are able to come back here and say, okay, cell B was the anode, so it was Fe 2 plus losing electron and electron to form Fe 3 plus. Remember, on the anode we said there is loss of electrons. So you write direction going backward, because on the anode you reverse the anode. The cathode, you write it the way it appears on table 4b with one arrow. So that is our language there. Then you know already they are going to ask you either to write this direction at the cathode or direction at the anode, and you are able to get it. So you have seen that is the ion half cell. Now, write down the half cell for reaction cell B, which is what I just did for you there, and you are able to get your 2 marks. Write down the cell notation. You see, this issue is either will ask you to write the net or the overall cell reaction, or will say calculate the cell, write down the cell notation. And remember what we said? We said all clever learners, or you say ABC. So we're always emphasizing that so that you don't forget. It's the anode, Sol bridge, and cathode. Remember, when you get that 3 marks, you got a lot in terms of the paper. Out of 150, that is 2% of the whole paper. So it's important that you know how to write this cell notation. And then already you have identified that on the anode side, you had Fe 2 plus becoming Fe 3 plus. You see the mistake I've made there? You can't write a solid line, because 3 plus and 2 plus, they are all aqueous solution. So when they are all aqueous solution, you write Fe. So this will be wrong. You can't write a solid line between them because they have the same phase. So you must say Fe 2 plus, comma, Fe 3 plus, because they are in the same phase. And then we have discussed, you can't connect your electricity, your conducting wires inside the solution. You must have an electrode. So because you have aqueous solutions, 2 aqueous solutions, Fe2 plus and Fe3 plus, you are able to say, I'm going to take platinum solid as my electrode. You see the importance of platinum? We bring it when we don't have a solid. And then you are able to show your Sol bridge, the double lines. And then you're able to go to your cathode with Ag plus on the cathode, forming Ag, and they are in different phase, and so we're writing a line like that. Look at that, how beautiful that is. and then you wrote your cell notation, you have 3 marks for writing the cell notation. So you can see that you are collecting your marks here, and then you will be able to celebrate. Now we are saying write down 2 standard conditions. You see the issue of standard condition. We are still emphasizing. Start with your temperature and your concentration, because those ones, they apply to all these reactions. But when it comes to pressure, it affects when we have gases. So there's no gas here. With aqueous solution and solids, we don't have any gas. So you know definitely that the 2 standard conditions will be your temperature. You can't just say temperature. You must write it in full and say temperature of 25 degrees Celsius or 298 kelvins, and you will say initial concentration of 1 mole per cubic decimeter. Then you are collecting your 2 marks there for doing that. Energy conversion for galvanic cell. Remember here, we're producing electricity. So we are saying from chemical energy to electrical energy. In full, please, you write energy conversion is from chemical energy to electrical energy. Then look at how many marks you are collecting. Now, in this statement, they say the concentration of Ag plus. Remember, Ag plus is the one that is decreasing. Remember, Ag plus is reacting with the electron to form Ag solid. So you are expecting that the solid Ag is increasing in mass because there's more solid Ag that is being formed when Ag plus accept or gains electrons at the cathode. So Ag plus is increasing in mass. What is happening to the concentration of Ag plus? Is decreasing because it's busy reacting with the electrons there to form Ag plus. So you will see that, okay, the concentration of Ag plus cannot be that 1 mole per cubic decimeter that we started with. The concentration is decreasing. And as the concentration decreases, the EMF of the cell will decrease. So if you increase the concentration of Ag plus, it simply means that now you are increasing the EMF of the cell. Hence, you will choose increases there as your option, because when you increase the concentration of the aqueous of the electrolyte of the solution there, which is Ag plus, you are increasing the EMF. So I hope you got that and you are happy with the answer that we got. Now, as we move, that is your marking guideline. We have discussed all this, and I hope you are happy. We're able to get our 0.77. We're able to write the half fraction that takes place at the anode. We're able to say platinum must be there because Fe2 plus and Fe3 plus are all aqueous solutions. Remember, I said you can include the concentration of the solutions there. And then the temperature, we said, is 25 degrees or 298 kelvins. The concentration, initial concentration, we said, is 1 mole per cubic decimeter. And then you are able to write that. And then we said energy conversion for galvanic is from chemical energy to electrical energy. And they said, when you increase, I want you to have that in your mind and let it be part of your understanding that when we increase the concentration of the ions in the cathode ions, when we increase those concentration of the ions, metal ions in the cathode, we are going to increase the EMF of the cell.